It's a new idea for you. Suppose this is x-axis. You've already learned about the x-axis and y-axis, and this is the y-axis. And this is a curve. A to B, it's a curve. This is x-axis and this is y-axis. Suppose the value of value at A this is xa. This is xa. That means the value of x corresponding to the point A, that is xa. Similarly, the value we elongate this line, we will get now this is value of x, this is xb. Actually, this line is continuous line. Similarly, the value of y corresponding to A is equal to ya, like this. And value of y corresponding to B is equal to yb. This is very simple idea. I am not mentioning any book, not mentioning about anything study material, just from your previous conception we are giving here. So this picture, so x ranges from xa to xb. Similarly, y ranges from ya to yb, mistakenly, and xa, ya. Okay, so, and you have to consider for each value of x, the value of y is unique. That means there is a unique value or only one. If this language seems to be difficult for you, the value of y is single. Only one value. For each value of x, when x is fixed, y is fixed. That means when x is fixed, y also fixed. Okay. So these points are continuous. This is a point, this point, these points are continuous. And x changes in this case. We see here x increases, y increases up to a certain point. Then x increases but y decreases. Then again x increases with increase of y increases with increase of x, and at this point y does not increase, y is almost constant, and then again y increases with increase of x. So this is the mode of change. We may express this change by a suitable mathematical equation, though the mathematical equation is not given here. So this is the curve. Only one curve is given here, and in this curve we have said x changes from xa to xb, and y changes from ya to yb. And third information, what is the third information? For each value of, so this is first information, number one information. Number two information, this is second information, y ranges from ya to yb. And number three information, for each value of x, the value of y is single. That means when x is fixed, y is also fixed. That means y has no two or three values for one x. Y has only one value. So this is the nature of this graph, and the nature of this set of information 1, 2, 3 gives this information about this, and this graph gives the same information. Okay, now we're going to page number 4. Similar graph is being drawn here. This is y-axis, this is x-axis, and this is the graph. This is the graph. So this is y, this is x, this is origin, and particularly we are taking a small portion of this graph. Suppose we are taking this section, this small portion of this. Between A and B. So there is a graph like this between A and B. This is a part of the graph A and B. Now we are drawing this more clearly for your convenience. We are taking a small part from A to B. This point is A, this point is A, and this point is B. And from previous conception, you can say x changes from this point to this point. So this is the change of x, and this is the change of y. This is the change of y. This is the change of x from this point to this point. And we are giving very small difference. This is for very small difference. This difference is called delta x. Delta x is equal to xb minus xa. What is xb? This is xb, and this is xa, and this is xb. Similarly, this is ya, and this is yb. So the difference between yb and ya is called delta y. Delta y is equal to yb minus y. Okay. Suppose xb minus x is equal to x is equal to 3 unit and yb minus y is equal to 4 unit. That means at this point from A to B, if x changes by 3 unit, y changes by 4 unit. So this is the mode of change. Y changes by 4 units and x changes by 3 units. Actually units. Now we are drawing this picture again here. From A to B, from A to B, almost from A to B. This is A, this is B. From A to B, we have obtained two lengths. One is delta x, this is delta x, and this is delta y. So this is delta y, and this is delta x. Let us give a name of this point. This is C. So this will be C. So BC is equal to delta y, and AC is equal to delta x. Delta y is change of y due to change of x. X changes, and also with the change of x, y also changes. And delta y is the change of y, and delta x is equal to change. And this change is small change. Suppose this is also small change. Though this change may be a considerable change, but this change is very small change. Now, delta y by delta x, if we draw this picture like this more concretely, suppose this picture, actually, this picture has been drawn here more clearly. This is delta x, and this is delta y, and this is point A, this is point B, and this is point C. Suppose this angle is theta. This angle is theta. We know from our knowledge of trigonometry, delta y by delta x is equal to tan theta, height by base. Actually, if this angle is theta, then height by base is known as tan theta. So this tan theta or delta y by delta x, this ratio, delta y by delta x, this ratio gives rate of change of y with respect to x. Delta y by delta x, in language if we write delta y by delta x is equal to change of y with change of x. This particular sentence have a special name in mathematics. This is called rate of change of y with respect to x. This slide, this sentence is known as rate of rate of change of y with respect to x. Actually, these two sentences are equivalent to each other. That means we can say if we get so, if we get or if we it is a very important idea about mathematics, also physics also. And in case of physics, it is very essential. Rate of change, that is continuum. Rate of change and delta y by delta x has been termed as like this: rate of change of y with respect x. Now we are drawing another another graph. This is x and y, and this is also another x and y. Suppose this is a graph. This is a graph, and this change is delta x, and this change is delta y. And similar, delta x is taken here, same difference. And when we are going to draw the value of or find the value of delta y, this delta y is considerably higher value. This delta y and this delta y at point mn and at point AB, this delta y at point m and n, and this delta y corresponds to point A and B. Delta x, it is also delta x, and we have taken this delta x between A and B is equal to delta x between m and n. That means delta x between m and n, A and B, A and B is equal to delta x between m and n. Now concentrate to this figure. In this case, if we draw this picture in different way, like this, delta x and delta y, and this picture will be like this, delta x, sorry, delta x, and delta y. Just concentrate between these two figures. This figure for A and B. This figure is for A and B, and this figure is for M and N. Okay? So this point is M, this point is N, this is A and B. Delta x for M and N and delta x for A and B are same. These two lengths are same, but this length delta y for M and N is higher or greater than delta y for A and B. That means we can say delta y for M n is greater than delta y for AB, then we can say rate of change of y with respect to x is higher than. At this point, the rate of change is higher, and at this point, the rate of change is lower. That means a similar graph, when the graph is like this flat, the rate of change is lower. Rate of change lower. But at this portion, the rate of change is higher. Because at this portion, this angle theta 2, this angle theta 1, theta 2 is greater than theta 1. If theta 2 is greater than theta 1, then we can say rate of change is higher. So we can say theta 2 is greater than theta 1, or we can say rate of change is higher at this point, between these 2 points, and the rate of change between these 2 points is lower. So same information can be given by two different languages, by two different modes. If we say slope, one line, slope, slope is higher. That means theta is greater. That means tan theta is greater. Tan theta is greater. So three languages, three sentences gives the same information. Slope is higher, slope is lower. This is called slope. So delta y by delta x is called tan theta, is also slope. This is also slope of the. So three languages, delta y by delta x, rate of change of y with respect to x, or tan theta, or slope of the graph. All the languages, all the indicators, all the informations give same information or same nature of the graph, but it is spoken in different languages. So very simply, you can say what is delta y by delta x. You have already known the value. And what is slope? You have already understood that value. Now, one more small idea. There is, though the implication of the idea is great, one of the greatest ideas of humankind, but for simplicity and for sake of time, And for our main sake of our main discussion, we are going to complete this class after just a few minutes and giving a very small idea. Now, you have to imagine one thing. What is the imagination? Suppose, suppose this is a graph ranging from A to B and 2 points P and Q, P and Q, two different points here. Now, if the points P and Q are very, very close. That means P point and Q point are close, very, very close. So, close. P and Q, though the points are given here at different points, they are very, very close. How much? What you are imagining, they are close. The difference between the distance between 2 points is very small. What you are imagining, it is less than that. That means if the distance between 2 points is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, continuously 0 and then 1 centimeter. There are numbers of zeros, centimeter, a large number of zeros. So this is the abstract concept. We cannot express such a long number in our book. We cannot, but we can imagine. So when these 2 points are too much close together, then we can say P tends to Q. That means point P and point Q are very, very close. And then the difference between 2 points is delta x. That delta x is known as delta x is equal to, then it is termed not delta x but dx. So dx is very, very small change of x. Very, very small change of x. And due to this very, very small change of x, if due to this very, very small change of x, if dY is change of y, and this may be considerable change, this may be very small change, it the value of dy may be large or small, but the value of dx, that is very, very small change. So there is a very fine difference between these two ideas, dy and dx. Those two quantities are written in same manner, but in this case, this variable, the change is very, very small in this case. But in this case, it cannot be very small. It can be very small, it cannot be very small. It can be considerable. Then, then that quantity, similar quantity, dy by dx, it is known as it is known as rate of change y with respect to x. And dy dx is equal to slope of the graph at that particular point, and that is dy dx is equal to dy by dx or ddx of y. It's called is equal to tan theta. Okay. Now, if 2 points are taken, P and Q, and a graph a, like this, a triangle is drawn here. A triangle is drawn here. This is also dx, also dy, and dy by dx is equal to tan theta. Okay. So this is about slope. This is slope and rate of change. Slope and rate of change are similar, close idea. And this is all about this class. Next class, in next class, we shall discuss about differentiation. So follow my classes for next time. And I shall discuss about differentiation. So though these classes are not pure mathematical classes, this is necessary only to understand physics. Okay, thank you.